managing processes on a system. That's it. That's all I've got for you. So, yeah, in this video, we're basically going through process management. We'll be looking at a few different ways we can manage processes on the system. Get the PID, the process ID, background jobs, foreground jobs, jobs. I'll stop talking. Let's just go. So, here we are in our beloved VM that we've spent so much time in throughout this series. I'm going to go as quickly but as clearly as possible here because there's quite a lot to get through. First command is jobs. As you can see, does nothing as it stands. That's because there are no jobs running in the background. There are no jobs running anywhere at the moment other than the stuff that's happening already on the system. An example of a job, just for example here, is pretty much any command, but I'm just going to do the sleep command and I'm going to do that for 10 seconds. Sleep will essentially sleep for 10 seconds. So I'm just going to talk for the 10 seconds and you'll see eventually this command will finish after the 10 seconds are up, which should be any second now. There we go. That was good timing. It hangs. So if you're doing something in a script and you need something to happen and then wait for a certain amount of time before you then carry on with the script, that's a way of doing it, is the sleep command. So I'm going to run sleep for 60 seconds and I'm going to stop that job now with Control Z. And as you can see, it's now stopped. If we go through this, we've got a job ID. The plus means it's the current job. It'd be a minus if it was the previous job. And if it was the previous job before that or any other ones, there'd be nothing next to it. You've got the current state and you've got the command itself. Okay. Now, if I wanted to foreground that job, I could do FG%1. I could do FG because it's the only job that's there. So if you just run FG or BG by themselves, then the current running job, as it were, would continue essentially. So if I foreground that, it will carry on the sleep 60. If I background that, it will background the sleep 60, which we can see again with jobs. So if I wanted to foreground that again, I could just type FG and it would put it into the foreground for me. I'm going to stop the job again because I'm just going to show you a few other commands as well. So some of the other commands we can do is we can get the process ID out of the job by putting jobs-L. And that will give us this number here, which is the process ID, which we can use later on to kill the job if we wanted to. We could also just get specific information on the one job itself by doing jobs % and then the job ID, in this case is 1, and that will give us that. And now just to elaborate on that a bit, I'm just going to run a couple more sleep commands for 120 seconds and then stop that one, and then we'll do one for 240 and stop that one, and then one for 480 and then stop that one. Oh, I think I caught something there. Let me just check the status of jobs. Yep, I did. So I'm going to do that 480 again and stop. I think I caught the X, which is kind of like a kill. So yeah, we can see now I've got all these jobs. I've got the current one, which was the 480, the last one I ran, which was the 240, and then other jobs, essentially. Now, if I was to background one of these two jobs, they wouldn't become the current job. They'd just become a running job. Case in point, I will do jobs... sorry, not jobs. I'm going to do background and then we'll just do %1 and then run jobs again. And as you can see, that's now actually it's just finished. The 60 seconds are actually up. So they're not running in the background. So it's not waiting for 60 seconds to pass in the same way. It's done. Those 60 seconds are up. But you can see now that it never got the plus, it never got the minus. It just carried on, as it were. So we'll do the same with number 2 now. I'll do that on number 2 and we'll background that and we'll do the jobs and you'll see that's now running. And it also has this little ampersand next to it, which I'll get into in just a second when I show you how to background a job or background a command from the get-go. So as you can see, yeah, there's a few different things you can get at the jobs command itself. I usually do go for jobs-L myself because that gives you the process ID. If you just want the process IDs to be printed out, you can do -P, but without the job information, it can be pretty useless in my opinion. You can also get the current job by doing %+, and you can do the same for the previous job with %-. So yeah, there's a few things you could do with that jobs command itself. Now, as I said, we can foreground jobs with FG. We can background jobs with BG, with the %1 and things like that. But how do we background a job from the get-go? Well, let's do sleep again. We'll do sleep 60. And all we'll do is stick an ampersand on the end. By sticking an ampersand on the end, we're saying background this job straight away. So as you can see, it's not taken over the actual terminal itself. It's just said, here's a job ID and here's a process ID. Now you can also see that the sleep 120 just finished and we've got a notification of that in the terminal. So you will get notified when stuff finishes if it's backgrounded. So if I now do jobs L, we can see I've got 2 stops jobs. Again, we've got that current job and the previous job and then this backgrounded running job. Now, because I backgrounded that job and it's running, it's still just chucked straight into the background. It's not considered the current one. I could foreground that current one, number 4, by doing FG. So it's not the order in which you run them. It's more like the order in which they were ran, then potentially stopped. It is a better way of wording it, I guess. So yes, that's the jobs command. So I think I'm going to leave that there as jobs in a nutshell. I managed to do that in about 5-6 minutes, so that's pretty good. Let's go on to the next section. So the next one would be, actually before I do, I just want to cover one last little thing here. If I was to exit out of this terminal, so let's just have a look at our jobs here. So if I was to exit out of my SSH session here, or just close this session, that job there would be hung up. It would be killed straight away. So case in point, I'm going to exit and then reconnect and then do jobs. And you can see there's no jobs running now. So what if we wanted to run a command that carried on after we exited the terminal? That's quite simple. We do nohup for no hang up, and then we just do our command afterwards. In this case, I'm just going to ping 8.8.4.4. And to show this working, I will run this. It will start pinging the Google name servers, in this case, the Google DNS servers. And when I exit out and come back in, that will still be running in the background. I don't think I've actually covered ping before, so I'll just quickly show you what's going to happen here. It's just ping. It's like sonar. I send an ICMP request out. It hits the servers and it responds saying, yeah, you hit me, essentially. And you can see this is what's happening in the background. You've got an increment in here, the time and other bits. I'm not going to get into it right now, though. So what we'll do is I'll cancel that. I will then run nohup and press enter. And you can see here it's saying ignore an import and append an output to this file. So if I, of course it will lock it up because I've not backgrounded it. So I'm going to have to background that. But just to show you, that file will now exist. I appear to have some test files here from previously. Let me just remove those. Yep, okay. So if I cat out nohup.out, you can see there that ping was running in the background. So I'm going to remove that file and I'll rerun that again, but this time I will background it. So 1 second, let me find it. Put the background tag on. I could have just Control-Z'd it then and put it into the background normally, but I just wanted to show my example here off the bat. So, you know, I quickly need to do something and then I need to run off, which means I need to log off of this server. So I'll press enter on that. That's now backgrounded. I will exit out and then I will come back in and we can see if I tail F, what was it? Ping nohup, yep. We can see that's still actually running in the background now. That's still happening. So it won't get hung up when I exit out of the shell. And if I wanted to kill that, we run jobs. Well, it's not there, is it? So how would we kill this? That's pretty simple. We can take a look at that nohup file again. And we can see in here, we've got this ping command running. We've not got a job ID for it though. So how would we get a job ID? Well, we could, if we scroll up, we could have taken note of the job ID when it started running, which was here, but maybe we didn't have that. How could we find that? There's a number of ways, which we'll get into in just a moment. But for now, I'm just going to take note of that job ID and kill it. So the kill command allows us to end a job ID. So it's 1835. So if I type kill 1835, we will now see if I not got a output saying done or killed or anything like that. But if I tail out that file again, we can see that it's actually finished. It's not happening anymore. Okay. So I'm going to remove that file and we'll move on to the kill command. So the kill command, as I said, allows you to provide a process ID and it will kill the command. So let's just do some sleeps again. We'll do a sleep 120 and I'll just stop that and background it. I could have just put the ampersand on again, but you know, different ways, it doesn't really matter. Now if I do jobs, N, we've got the, L, not N, we've got the process ID here. So as I say, we can do kill and then the process ID. which is 1971. And that will kill the command. There are different types of kill though. This will terminate the command, so it will let it gracefully finish essentially. If I wanted to just kill the command there and then with no care for anything that's happening, so there's things called sig hang up, sig kill. So for example, if I do sig hup, this will send a hang up command to that, and you'll see it's hang up has now happened. This is the status there. If I now do the same thing again, sleep 120, and background it, I really just need to put the ampersand on the end of that, and then we'll get the job. So that's 1974 there. So I'm going to do a sig kill there, and we can see this time, oh sorry, I need to change that process ID. See, this time it's been killed instead of terminated or hang up happened. So there are different things that we can do. The other one is sig term. So one more time, we'll do a sleep. I'll actually background it straight away this time, and that's 1976. And this time I'll change to sig kill for sig term, and you'll see this time it's terminated the command. So kill will just stop it there and then. Terminate will allow it to gracefully finish essentially. So it won't wait for it to finish the end of the 120, the sleep 120. It will just say once the process hits its natural cycle end. It's a hard way of describing it, but it won't just stop it dead there and then. And the hang up would act in the same way that it would if you were to just exit out of a terminal. Okay. So that's the kill command. There's also a kill all. So if I had sleep 120, 120, 120, 120, let's just run a few of them. We'll run jobs. Now you can see I've got a number of sleep commands running. I could do kill all sleep. This will kill every single command that's running that's called sleep, essentially. So if I had 10 pings running or 10 other commands running and I wanted to kill them all at the same time, then I could do that. And again, it runs the sig term there. So it terminates the commands. And yeah, that's kill and kill all. There are other ways of getting the process ID, as I mentioned before. So for example, if I did that no hang up command, let's just go back and find that. So we'll do that. And we can see, yes, I got 1985 there. But what if I logged out, come back in and do jobs? Well, I don't know what the process ID is anymore. You know, it's been 3 hours since I ran it. And what was that process ID called? Well, we can do something called pgrep. So pgrep, and then the name of the command, in this case, ping, will give us the process IDs of any ping commands running. Now, it's worth being careful here, obviously, because if I have 10 ping commands running, I'll get the process ID of all of them. So obviously, just be careful as you do this. You'll probably want to take that process ID and check it against something else to make sure it is what you're looking for. And another command we can use is pkill. Much like kill, it kills a command based on its name instead of the process ID. So in this case, I can do kill ping. So this is like kill all, but yeah, pkill, ping, we can kill that, and we can see that the ping command will have finished. So if I just tail F the nohup command again, you'll see it's no longer running. The sequence is no longer increasing. And I'm just going to remove that file. That's the pkill and pgrep commands. So we've done jobs, we've done kill all and kill, we've done pkill and pgrep. What else can we take a look at? Well, we can take a look at top and ps. So I'm going to just background some commands again. So for example, the sleep, we'll do 240, just so I've got time to go through this. And I'm going to do top. So top is kind of like the task manager in Windows, if that helps. And there's a number of things we can do with top. It's a pretty powerful tool, but not many people use it in its powerful way because there are other tools available. So I'm just going to quickly go through. Capital M will sort it by memory usage. And as you can see, we've now got the highest memory usage at the top. Capital N will sort it by the process ID number on the left here. Capital T will sort it by its running time, which is this command, this section here, the second from the last. Capital P will run it by order it by CPU usage here. So again, maximum first. So other interesting things we can do with top is if we do question mark or H, we'll get the help, and this will give you a lot more information of stuff you can do. One of those things is you can kill a process. So if you do K, it will then ask you for a process ID. Now, I don't know the number of my sleep. I didn't pay attention to the number as I entered top, but if I just quit out, so Control C and scroll up a little bit, maybe I'll see, no, what about jobs? Okay, so if I do jobs L, 2115. Okay, so let's go back into top. Just to show you how it works, so I can do K, 2115, and then enter, and it will say send PID 2115 signal, sig term. Just press enter again, and that will happen. Now, if I close that at top, you'll see here, we have a termination notice. So You can kill commands through top. You can change the priority of a process called renicing. So if I do R, then I can change the process. Possible values range from -20 through to 19. The lower the number, the higher the priority, essentially. So it's kind of like making something run in real time, if that helps and you understand that a little bit. So you can do this in Windows again. Via the task manager, you can right click on something and change the process's priority. This is what that is. It basically allows the command to get priority on the CPU. That's essentially what happens. So if things are locking the CPU up, this would get a higher priority. That's what renicing is. I was going to do a whole video on nice and renice, but I'm not actually going to do that because it's useful, but I rarely use it myself. But there are scenarios where you might want to use it. But just for the sake of going through what that is, we can renice something with the renice command. And if I do man renice, you can see how you would do that there. So you can get the priority using -n, and it gives you a couple of examples here. Look, so you can say renice, the value, the process ID, and yeah. So have a look into that. The nice command also exists. So you can set a program when it runs with a nice value. It sounds a bit of a weird command name, renice and nice, but yeah, it's good to know about. So I'd say have a little look into that on the side. I'm not going to go into it in depth right now. I might do in a later video. We'll see. So another thing you can do is -u. So which user do you want to show the processes for? Well, I'll run it for Drew, and I'll just get the Drew processes that are running. And there's a lot of other stuff. So we can do capital V, sorry, which will give you the tree of the commands. So this is where we come in, we logged in via SSH, hit a bash shell, ran sleep, and now we're running top. And they're both running on the same level. So parent-child kind of relationship in that way. Finally, we'll take a look at W, which if I do capital W, it will say it's wrote the configuration. If I just do that again to this location. So it just means that if I cancel out of top and then come back in, my settings are saved. For example, my tree is there now. Okay. The one other last thing I want to kind of go through is this lot up here. So if I do T and M, we can change how it's look. So I can say, show it as a percentage. So that's T. And so T does the CPU bit, M does the memory and swap. So you can change how things look essentially, or whether it's hidden. And if I do capital W again, cancel out and then come back in, they will stay like that. So yeah, we can go through a few different bits. The last thing I'm going to go through is just the output itself. So let's have a look. We've got here top. It gives you the uptime and the actual time itself. So the time itself and the uptime there, how many users logged in, and the load average on the system. It's got the number of running tasks, the total number of tasks, the number of tasks that are sleeping, how many have been stopped, and how many are zombied. Zombie process being something where they've completed execution, but they're still waiting for their parent process to remove them from the process table. You will come across this from time to time, but I'm not going to get into zombies right now. Then you've got the CPU itself. So if I just go back to the original view of that, let me just bring that back, and that we can see here we've got the user processes, the system processes, the process set to a nice value. So we haven't niced anything, so that's at 0 at the moment. We've got the idle time of the CPU, the wait time of the CPU, and what else have we got here? We've got the hardware interrupts, software interrupts, and the processes that are serving other virtual machines tasks in a virtual environment, also known as steal time. So if we have VMs running, that will go up. And for memory and swap here, we've got the total amount, we've got the free amount, we've got the used amount, and then in terms of memory, the amount that's buffered or cached, how much is basically ready to use by something, and in terms of swap, the available amount. So that's top's output essentially. And then we've got here the process ID, the user that's running, the priority of the process to the kernel, the nice value, the total amount of memory used by the process, including swap, the RAM used by the process, so that's what the res stands for, the shared amount of memory with other processes, the status of the thing itself, so whether it's sleeping, zombied, stopped, runnable, other things like that, the amount of CPU it's using, the amount of memory using, the time the command's been running, and the command itself. That's top. There's a lot there. A lot of people just use it to quickly take a look at usually the load average, I've noticed in my experience. Well, if you want that, you don't need to do that. You can just do uptime, and that will give you the load average. See, that line there is just that line there. It's the same. So top's actually really powerful. It's just I've noticed in my experience, a lot of people don't use it how it can be used. And then finally, we'll have a look at the PS command. So if you do PSA, I'll just clear my screen. You've got the, it shows a snapshot of processes essentially. So this is all the processes within the terminal. So this is what's running at the moment. We can look at it in different ways. There's the BSD output, the Unix output, and the GNU output, or the, not that output, the usage style. So you've got PS, P, for example, and then a process ID. So let's just have a look, see if that job's still running. Nope. So we'll just run a sleep command again. That's 2177. So I can do PSP 2177. And that will show me the sleep commands process. Now, if I do the same thing, but with -p, that will give us the Unix one. So the first one was BSD, this is Unix, and then the final one is --PID. And you can see they pretty much give the similar output, but the BSD version also gives you the status. So, you know, it's whatever you feel more comfortable with. But the flags do the same thing, essentially. It's just how it's output and the way the flags, so the double hyphens are usually GNU, the single hyphens are Unix, and the no hyphens are the BSD one. That's kind of a way of looking at it. It's up to you which one you want to use. We can get the process for a specific user, so PS, and then in the case of BSD, capital U, lowercase u for Unix, and ---- user for GNU, and the name of the user. So I can do that. Don't have to, you can have a space there, and that will show me the user Drew's processes essentially. Again, I usually go for the BSD style just because it gives you that little bit more information on the status itself. So yeah, if I just again show you it with the Unix style, you'll see the only thing that changes is that stats column, and that's it. So yeah, that's again, it's up to you, completely up to you. So the A gives you all the processes. The U gives you the user-oriented format, and if you use X, it will show you the processes that are not attached to this current terminal. So I can get everything with AUX. So you can do that, and you'll get every single process. You'll see all of this stuff was in top. If I just quickly go back to top and get rid of the tree view, you'll see stuff like, I don't know, migration one there. And if we go for PSAUX, you'll see in here somewhere, there you go, migration 0 there. The migration 1 will have been there somewhere too. So yes, that's the PS command. So again, we've got the columns at the top. Let's just go through them. And you'll see there's a few more columns with the X as well. So you've got the user, you've got the process ID, the amount of CPU being used, the amount of memory being used. You've got the virtual memory of the process in kilobytes. You've got the non-swapped physical memory being used. You've got the TTY, or the terminal that's controlling the process. So all these question marks usually mean it's just something that's started on boot, or it's not really in a terminal itself. And you'll see the rest of them. Some are running TTY1, some are running on SSH. That's what the PTS0 is. And then if we go back to the top, we've got the stat, which is the status, the same as top. You've got the start, so the time it started. You've got the time that passed since it started, and then the command itself. And that's pretty much it for PS and top. That's where I'm going to leave that. So that's everything for process management. We are going to be going on to a few other bits around file management and bits like that shortly. We're coming to the end of this series now. So in the previous video, I actually recorded that after this video, but I ended up putting it up before this video because the camera bits I'm actually doing all now. So the next video, this video, and the previous video, I've actually I've done all the camera bits now. The only thing I've done is quickly gone and changed my t-shirts and some clothes because, you know, I don't want you lot thinking that I'm wearing the same clothes day in, day out for many weeks on end, which is what it would have looked like if I'd have just done it all in the same clothing, basically. So, yeah, I'm a little bit out of order here, but it doesn't matter because the context is still the same. The content is still the same. You're still going to hopefully learn something from it. I'm going to stop talking anyway. So next video, I think, is file management. Maybe not file management, file permissions, file system management. It might not be. I don't know. Everything's gone out of order. So you know what? I'll just see you in the next video.